Good morning, learners. In this video, we are looking at the analytical geometry questions from November 2018, question paper 2. That is question 3 and 4. So we're going to start with question 3. In the diagram K, which is -1, 2, L, which is not given, and N, the point 1, -1, are vertices of the triangle KLN, such that LKN is 78.69. KL intersects the x-axis at P. There it's shown KL is produced a little bit there. The inclination of KN is theta. The coordinates of M are -3, -5. I don't see MO there. M, -3, -5. There we go. So calculate the gradient of Kn. I have the 2 points. I can just use my gradient formula. A lot of easy marks a lot of the times in the analytical geometry. The gradient of Kn. If K is given as -1, 2, I'm just going to write the coordinates here, but it's given on the sketch. And N is 1, -1. So difference in Y, -1 minus 2 over difference in X, 1 minus -1. And you can type this into your calculator just like that. It should give you -3/2. Next question says calculate the size of theta, the inclination of Kn, right? So I just calculated the gradient of Kn. Tan theta should be the gradient of Kn. So tan theta is -3/2. And whenever you have a negative gradient, you should just remember to take plus 180. So 180 plus the shift tan -3/2, -3/2 is going to give me 123. Just know that you're going to have an obtuse angle, not a sharp angle. You see, without that plus 180, you should get a negative angle. Whoops. I get -56. Which that does not make sense, that my angle is -56 degrees, but that's the acute angle size that you must subtract from 180 to get the obtuse angle. Okay, and then question 3.2 says show that the gradient of KL is equal to 1. Okay, so I can easily get that, let's call that angle there alpha, right? I can easily get that alpha, which is the inclination angle of KL, because can you see exterior angle equal to opposite to interior? Alpha is going to be theta minus 78.69. So let's just call it KPO. KPO is alpha. So alpha plus 78.69 is equal to theta, because the exterior angle of a triangle equals the opposite to interior, sum of the opposite to interiors. So alpha is theta, which is 123.69 minus the 78.69, and that gives me, I think, 45. 123.69, subtract this 78.69, giving me 45 degrees. So alpha is the angle of inclination of that line KL. So tan alpha equals the gradient of KL. Right, so the gradient of KL is equal to tan alpha, which is 45, and tan 45 is 1. and that this is what they wanted me to show, that the gradient of KL is 1. Okay, so question 3.3 says determine the equation of the straight line KL in the form y is equal to mx plus c. I have the gradient is 1. I have a point -1, 2 that lies on the line. So y is equal to mx plus c. The gradient is 1. So, and the k -1, 2 lies on the line. The y is 2. The gradient is 1. The x is -1 plus c. And from this, I can get my c value as 3. So, the line equation is y is equal to m, which is 1x, plus c, which is 3. And there's that line equation of KL is y is x plus 3. Okay, 3.4, calculate the length of Kn. The length of Kn, also not very difficult. I have the two coordinates of K and N. I wrote K there, let me just write N here again, is 1, -1. So the length of Kn, distance formula, is difference in x, so -1 minus 1 square, plus difference in y, 2 minus -1 squared. And you can type this in your calculator just as it is there. And that gives me root 13 length of Kn. I would rather make it a decimal, 3.605, so 3.61 units, and then 3.5 says if it is further given that Kn and Lm is equal, Kn and Lm is equal, so there that length, which is now 3.605 for root 13, this length here is also root 13. Okay, calculate the possible coordinates of L. Well, actually, if I have, I'm now thinking of using the distance formula, but that's going to give me two missing values there, which is not good. But now also I want something that lies on KL, and I have the equation of KL. So possible coordinates of, this is 5 marks, possible coordinates of this question will be where, if I substitute this into the distance formula and that equation, and I do simultaneous equations, should give me, but that should actually not just give me possible values, that should actually give me the value of L. Is what I think to do. And yeah, I think let's try that. So what I'm going to do here is, in the distance formula, the distance of ML, length of ML, it's now that length there. The length of ML is root 13, but ML distance formula is root of xm, which is -3, minus xl squared, plus difference in y, -5 minus y value at L squared, and this is going to be ML is root 13 is equal to root of -3 minus XL squared plus -5 minus YL squared. This is one equation in terms of XL and YL, but then I also know XL and YL lies on the line KL, which I calculated the equation of as y is equal to x plus 3. So I also know that YL should be equal to XL plus 3, since that lies on the line KL, right? So I can replace this YL there maybe with XL plus 3, and then I have only XL missing in that equation. And I'm going to have to start on a new page here. So I have, and I'm just going to drop I'm not going to write the square roots anymore since there's both sides. I can square and then I'm rid of both of them. So 13. 13 is equal to -3 minus x squared plus -5 minus, and YL I said I'm going to replace with XL plus 3. So minus there, XL plus 3 squared, like that. And I'm just going to simplify this bracket a little bit before going on. So I have -3 minus x. Let me just write it twice, -3 minus x. And this is going to be minus x and then -3, but there's also -5. So -5 minus 3 is -8 squared, which means I can summarize this bracket twice as well, minus x minus 8. And now I'm going to have to work this out. I'm going to jump the 13 over as well. So -3 times -3, +9. This is +3x, +3x, so +6x and +x squared. Then plus negative times negative, +x squared, plus 8x, meaning plus 16x, plus 64. And now I have, let's just add the x squareds first. There's x squared and x squared, so 2x squared. And then the x's is 6x and 16x, that's 22x. 22x. And the numbers, I'm just going to quickly use my calculator, is 9 plus the 64 minus the 13. It's going to be 60 plus 60. And let's just quickly divide this by 2. So I have x squared plus 11x plus 30. And if I think of factors of 30 that maybe gives me 11, I can quickly think of x 5 and 6. 5 times 6 is 30, 6x and 5x is 11x, meaning that the x value is -5, or the x value is going to be -6. Right, I'm busy trying to find possible coordinates for L here. And I know that L is, I know that the y value is x plus 3. So this y value is going to be x negative 5 plus 3 is negative 2. So L can possibly be negative 5, negative 2. Or the y value can be x plus 3, negative 3. So the L value can be negative 6, negative 3. Negative 5, negative 2. Or negative 6, negative 3. I think it just means that if I take the same distance there, these two lengths are the same, that this length can maybe be, if I draw an isosceles triangle, can be there and there, that both lies on this line. So I have two possible values that's the same length there. So okay, I have two possible values for L. Now they say determine the coordinates of L if it is further given that KLMN is a parallelogram. And we've discussed this earlier, that you can use the cheat code from the x to the x. The same thing should happen. So from this x, which is 1, to that x negative 1, I moved back 2 units. So if I move back 2 units from negative 3, it's going to be at negative 5. Which means this one, 3.5.2. The L is going to be negative 5, negative 2. Let me just double check the y as well. So for the y value from negative 1 to 2, it moved up 1, 2, 3 units. And if I move from negative 5, 3 units up, it's going to be at negative 2. This is allocated 3 marks for, so I suppose you must just then explain, same as I did it in, I think, in another video. It's not in this video, so I'm just quickly going to show you how to write that. If it's a parallelogram, what happens from N to K will also happen the same from M to L. And what happened from N to K is I took the x value from N to K, the x value, and I moved 2 units backwards, and I took the y value of N and I moved 3 units up. Right, so the same is going to go from M to L. I'm going to take the x value of M and subtract 2, and then the y value of M and add 3. So since M is negative 3, negative 5, the L is going to be negative 3 minus 2 is negative 5, and the ym is going to be negative 2. So you can write this as your calculations there. This, I think, will be fine for calculations. Alternatively, what you can do, if that is a parallelogram, then the midpoint here of Km should be the same midpoint of Lm. So then you find the midpoint of Km and you make that the midpoint of this line with that point and the missing L value, and just establish in another way that the L is negative 5, negative 2. This is fine, or you can use midpoints, or you can use equal gradients. So the gradient of this line should also be the gradient of Km, which we already calculated as negative 3 over 2. So if you make this gradient here negative 3 over 2 furthermore, and just test with that these 2 points, you'll see that this one actually works out. Okay, so there's a few things to do actually there. 3.6 says T is a point on KL produced. If I take KL, produce it, somewhere further along the line I will find the point T. Tm is drawn, Tm there is drawn, such that Tm is equal to Lm. So further along the line I draw another line there, so that these two lines are equal. Tm is equal to Lm, Calculate the area of triangle KTN. KTN. The problem is that T is going to be this side. It's not going to be that side. Because I already know, oh, that's the point -6, -3. So I have that coordinate of T there as -6, -3. T is a point on KL produced. TM is drawn such that TM is equal to LM. I worked with distance to get these two coordinates there. Since this is L, that is then going to be the point T, which has the same distance then. It's -6, -3. Calculate the area of KTN. There we go. KTN. So I suppose the first thing to look for is a perpendicular height to calculate the area, or you can use the area rule, but I'm just gonna have to quickly look that up because I don't know that out of my head. The area rule from trigonometry is half AB sine C. So half KT half AB sine C. I have that. Do I have the length of Kn? I worked that out somewhere. It's 3.61 units. And can I get the length of KT? I have T, I have K. Yes, fairly easily. Right, so I'm going to start by doing that. Question 3.6, because that's something that's missing there. In half AB, the area rule, half AB sine C, I want to use the 78.69 as my C, that angle there, so I want to use these two lengths. Okay, now I know that Kn, so that's half. The Kn is, I worked that out earlier, root 13, just for purposes of accuracy. I'm rather going to work with a root 13 because the 3.61 was rounded. So I'm going to keep to the root 13 there. But I need the length of the KT. So I'm just going to start by working that out first. Okay, so KT, distance formula. If K is -1, 2, that's given, and T, I worked out most now, is -6, -3. Difference in X, -6 minus -1 squared, plus difference in Y, -3 minus 2 squared. You can type this into your calculator just as it is there. So, -6 minus -1, close the bracket, squared, plus bracket -3 minus 2 squared. There we go. 5 root 2. And I'm just going to first leave it like that. Just substitute it in there. Let's go here. That's my rough work. With the area is equal to half AB is going to KT and KN. Sine C, which is TK in that angle, TKN. So KT I calculated as 5 root 2, and Kn I know already is root 13, and TKN is 78.69, and just type that into your calculator. So I have half times 5 root 2 times root 13. I actually just want to put that in a bracket as well. Times sine 78.69, close that bracket. It gives me 12.499, so 12.50 units, squared units as the area. Okay, that's question 3. Now we are going to look at question 4. Okay, question 4 says, in the diagram, the equation of the circle with the center F, there it is x minus 3 plus y minus 1 is equal to r squared. Equation of a circle at the center 3, 1, given here. S is given as the 0.65. So F there is given as the coordinates 3, 1. If I know what the AB stands for, I'm just going to put that in there. F is the 0.31. S is given a point on the circle. Another circle with a center at MN in the fourth quadrant touches the circle with the center F at the point H, such that FH to HG is in a ratio 1 to 2. They're just telling me that this radius, if I make this the radius, this radius here is double the length, 2 times the radius, right? Of the smaller circle. The point J lies in the first quadrant there, such that HJ is a common tangent to both these circles, and JK is a tangent to the larger circle. Now I know the tangents from a common point are the same length. Write down the coordinates of F. Okay, so the coordinates of F is 3, 1. 4.2, calculate the length of Fs. Okay, that's just formula, distance formula, Fs. I have F there is the 0.31, and I have S there is the 0.65. So the length of Fs is going to be difference in x, 6 minus 3 squared, plus difference in y, 5 minus 1 squared. And you can use your calculator there. It's 5. Okay, the length of Fs is 5, which is the radius, by the way. Fs is the radius, so that tells me actually that the radius of the smaller circle is 5, which they didn't ask here, they just asked the length of Fs, but I'm just noticing. 4.3 says write down the length of HG, which I know is twice the length of the radius. Since HG is twice the length of the radius of the smallest circle, that means twice 5, it means 10 units. Okay. 4.4, give a reason why JH is equal to JK, because tangents from a common point are equal. 4.5, determine the distance FJ there with reasons if it is given that JK is equal to 20. So JK is 20, that means that JH is 20, because JK and JH is equal. So if I have JH, a radius and a tangent is perpendicular to one another, I have the radius is 5. I can get FJ by Pythagoras. I must just give reasons here. So I'm going to say FH is perpendicular to JH. FH is perpendicular to JH because a tangent is perpendicular to a radius. I must first establish this is a 90-degree triangle before I can use Pythagoras. Right, I have JH is 20 and FH is equal to Fs, which is 5. I worked that out earlier because the radii are equal. Okay, so I can say that Fj, which is the one I want to work out there, it's the hypotenuse of that triangle. So Fj squared is going to be 5 and 25 squared and 20 squared by Pythagoras. That's 425, meaning Fj is the square root, which is 5 root 17 or 20,62 units. 4.5.2 says now we are busy determining the equation of the circle with the center G in terms of M and N in the form there. Okay, in terms of M and N, so M and N is the center of the circle. That shouldn't count a lot of marks. 1. It's going to be x minus m squared plus y minus n squared is equal to, that radius was 10 if you remember, so 10 squared, which is 100. Okay, and 4.5.3 says the coordinates of G. If it is further given that the equation of the tangent JK is x is equal to 22. So this equation here, x is equal to 22, is exactly perpendicular to the x-axis, right? Because perpendicular lines have equation x is equal to constant, and horizontal lines, vertical lines have x is equal to, and horizontal lines have equations y is equal to. Now, since this line there, radius, is perpendicular, that's 10 units, right? The x there is 22, and if I count back exactly, well, 10 degrees, that x value is going to be 12, because there it cuts the x-axis at 22, and perfectly 90 degrees to that and 90 degrees to that. You can see if I count back 10 units there, it's going to cut the x-axis there at 12. So GMN, I can immediately say that the M is equal to 12. Now I need to find the N, right? So I need a point on the circle to substitute, because I have that equation, and if I substitute the M in there with a point, then I only need to find the N. So I need a point on the that lies on the circle, which that one seems like something that's possible to get. That line there. Although I don't know the coordinates of the H there. I have the length. I'm just quickly trying to see if they maybe didn't guide me somewhere. They let me write the coordinates of F, the length of F is that length. which is the length of HG, those two are equal. Then the distance FJ, they made me calculate that, which doesn't really mean anything specifically, and I have the equation of that. I'm just trying to check if FJ is not maybe possibly gonna help me find that. I suppose obviously J and K is the point 22 something, right? Because the X is 22 there everywhere. And maybe if I have the length of FJ, right? Which I calculated, so I can substitute that into the distance formula to get the Y coordinate there. And if I have the Y coordinate there, I have the length of JK, I can subtract 20 to get the Y coordinate there. And the Y coordinate there and there is going to be the same. So that's something I can use maybe. I think that's what I'm going to do. So I have the length of FJ, which I calculated in the previous question as 10,62 units. Or root 5, 425. That might just be better to work with that. So I have the M. I'm trying to get the N, right? So Fj, the length of Fj is equal to the x value at j minus x at f squared plus y value at j minus y value at f squared, where j is the point 22 something, y value at j, I don't know, and the f coordinates is 3, 1, which I already established earlier there. Okay, 3, 1. So this is going to give me the Fj. I calculated as 20,61. It was actually the square root of that. So if I square this again by taking away that square root, Fj squared is going to be xj minus xf squared plus yj minus yf squared. You see, if I jump the square root over on the other side, it's going to become a square. And fj squared was 425, which is just an unrounded answer, safer to work with. So 425 is xj is 22 minus xf is 3 squared, which is 19 squared, it's 361. I'm just going to quickly do that. 361 plus yj, which I don't know, minus yf. So y minus 1 squared, which is then going to become y squared minus 1, minus y1 minus y, which is minus 2y plus 1. And this is a quadratic equation. Y squared minus 2y. 361 plus 1 is 362. Minus the 425 minus 425 is negative 63. 7 times 9. So I'm just going to quickly squash it in here. So this factorizes into y minus 9, y plus 7. So y is equal to 9 or negative 7. Okay. That's now for the coordinates of j. Now, obviously, that is going to be a positive y value, not a negative one. There's also going to be one there on that side. So, but we obviously want a positive one. That one's not applicable. Okay, so the y is equal to 9 there. Right. So my space on this paper is a little bit up. Let's just move to a clean page. Okay, so on this sketch, I have the y there as 9, right? So j is the point 22, 9, 22, 9, right? And if you look at the sketch, I have the length of fk, I think. jk. jk they gave to me is the same as jh, which for some reason, why do I think it's 20? jk is equal to jh. Oh, given that jk is 20, so jk is 20, jh is 20 units. So if this is 20 units, it's not reflecting in the x, it's reflecting in the y. So from there to the x-axis, I move 9 down, and then another 11 to move 20 down this line that's 20 units long. So this is going to be the coordinate at negative 11. And then since this is perfectly horizontal, this line equation should be y is equal to negative 11. Everywhere on this line, that coordinates is going to be for the y value 11. So the m value I said earlier is going to be 12. That makes k the point 22, negative 11, and that makes g, I said that coordinates there is 12 because 22 moved 10 back, is going to be 12, and then the 9 moved 20 down, it's negative 11, so the n is going to be at negative 11. There's the coordinates of g. Assuming now that jk is perfectly vertical line, right? And that then obviously a vertical line perpendicular to that will be a horizontal line. All right. And yeah, that is question 4. Oh, it's a vertical line. I'm just trying to find out or trying to see where did I get again that this was a vertical line. It's because they gave me the line equation x is 22. So that means that it's a vertical line. Right. Okay, so that is the analytical questions from November 2018 paper. Again, I hope this was useful to all of the grade 12s out there during lockdown. This is a tough thing to happen in your grade 12 year. I hope you're really staying motivated, doing some effort at home, and really working through some of the stuff. And I hope this helps you a lot. If you have any questions, be welcome. Or feel free to just pop them down below in the comment section, and I'll try and assist you further. Good luck with the studying, good luck with lockdown. Please stay safe.